Okay, here we go. Day 2. Day 2, we're going to look at matrices. That's our focus for this day. And one of the things we have to remember about matrices is the very first thing is that when we talk about matrices, we're going to always refer to matrices by its dimensions. Dimensions, remember, are written as the number of rows by the number of columns. So just keep that in mind as we move through matrices. So on this very first problem, we're given a table, and they converted the table of data to a matrix, and they named it matrix E. This represents this table. What is the meaning of the entry whose address is E21? Well, first we have to understand what is an address. Let's think back. An address is simply the matrix name with two little sub-numbers, and those sub-numbers refer to the number of rows and the number of columns. In particular, a specific row and a specific column. In this example, they are referring to the entry that is located at row 2, column 1. So in this case, they are referring to entry number 2. Okay? Looking at the next one, it says, what is the address of the entry number 5? Well, number 5 is right here. But when we look at number 5, we have to give its entry according to its row and column. So it is E for our matrix name, 1, 2, second row, and then column 1, 2, 3, 4. So it is E sub 2, 4. That is how you write your address. The next part moves right into looking at a matrix, and we're going to use this big matrix to answer questions 13 and 14. The first thing it wants us to do is write the dimensions of the matrix. Again, our dimensions are written as the number of rows by the number of columns. So matrix A is a 1 by 2, 1, 2, 3, 4, a 4 by 1, 2, 3. By 3 matrix. It has 4 rows and 3 columns. Okay. The next thing it wants to know is what is the address of element 8? Well, element 8 is right here, and just like before, our address will be written using the matrix letter for the name sub row column. So the matrix is A, lowercase a for my address. I am in the second row and the third column. So there is my address. When we are looking at starting to do operations with matrices, like in problem 15, they want us to add or multiply. But we have a caution here. Caution statement. Anytime you add or subtract matrices, you must have the same dimensions. That means they must be identical. So when I'm looking at this first problem here, notice the dimensions of matrix M are 2 by 3. The dimensions of N is also a 2 by 3. So is this possible? Yes. I can actually add those two matrices. Let's look at this next example. M is a 2 by 3, but notice they switched the size of the matrix N to a 3 by 2. Those dimensions are not the same. If I was to look at this, it would be 2 rows and 3 columns, but this is a 3-row 2-column matrix. Look, the sizes are even different. When this occurs, it is impossible for you to add the two matrices together. Now let's talk about multiplication. When I look at multiplication, another caution, when you multiply your matrix dimensions, row and column, the column of the first must be the same as the number of rows in the second. Your resulting matrix will be the dimensions of the row by the column, meaning your outward pieces of information. So let's take a look at this. Keeping this in mind, when we look at multiplying, I'm going to make sure I line them up in order matters. I have a 3 by 4 times a 4 by 2. Notice how the two inner pieces are the same. This is possible, and my resulting matrix will be of dimension 3 by 2. The next one. When I look at this one, I have a 3 by 4 M matrix and a 3 by 2 N matrix. These two numbers are not the same, so this is not possible. Again, your columns in the first matrix must be the same as the number of rows in your second matrix in order for you to multiply. So let's put this to practice. We have two matrices here, and you can do this with or without the calculator. If you're doing it without the calculator, you will simply add entry plus entry to find your resulting matrix. But if you want to make sure you make no mistakes, then let's use our calculator. So we need to go back over our steps for entering matrices. Here are our steps. Step 1, we're going to press second matrix. That's that x to the power of -1 button. We're going to edit our matrix, which means we're going to enter our dimensions and enter each item of the matrix. Then we will go to second matrix and select the matrix we want when we want to do our operations. So looking at this first example, I'm going to type in my first matrix and I'm going to type it into A. So again, I'm going to press second matrix, which is right here, and it takes me to this screen. I go over to edit, press enter, and now I enter my dimensions. The very first matrix I have here, that is matrix H, notice is a 1, 2, 3, a 3 by 2 matrix. So 3, enter 2. If I'm not sure if I'm doing this correctly, the calculator will definitely let me know, because you won't see it match what you have on your paper. And now I enter my individual entries. Once my matrix is entered, I press second mode to get out. Now let's go enter our second matrix. I'm going to follow the same process. Second, I press the matrix button, I go over to edit, and this time I need to place it into the second matrix. So I'm going to go down and select B. I'm going to enter my dimensions. Again, it is a 3 by 2 matrix. Because the dimensions are the same, I can add them. Enter my entries. Oops, syntax error. Oh no. Oops. That would explain it. There we go. Typed a little too fast there. Here's our second matrix. Now that we've entered our second matrix, we are going to second quit out of there, and now we're going to type in our problem exactly the way it's written on our paper. I'm going to add the two matrices. I'm going to go back to matrix, so that's that second matrix, and I'm going to choose the first matrix plus second matrix, the second matrix. Hit enter. There's my answer. I can copy it right down from my calculator screen. The great thing about using the calculator is that if it turns out to be impossible, your calculator will tell you it's impossible. Let's look at our next question. Our next question is a scalar multiplication. In scalar multiplication, remember, if you want to do it without the calculator, you simply take the number on the outside and you multiply it to each and every entry inside. But let's practice using our calculator. If we want to use our calculator, again, we must go enter the matrix. So I'm going to go right back to that second matrix. I can choose another one, or I can just rename A. I'm going to rename A. The dimensions for this one is a 1, 2, 3, a 3 by 2. Great, my dimensions are the same. I just need to type in the new information. 1, 1, 2, -7, 4, and 10. New matrix is entered. I'm all set and ready to go. Second mode to get right out of there. And now I'm going to type it as it's written. 0.5 times, and I got to go select that matrix again. How did we do it? Second matrix, and we're going to select matrix A because that's where we just placed that matrix. And then once we have it here, press enter and we're done. The calculator does all the work for us. Copy down our answer. 0.5, 0.5, 1, -3.5, 2, and 5. All done. To do our next problem, we're going to do the same process. Could you do this without the calculator? Sure. If you multiply each entry by 2, multiply each entry by 3, and then take your two matrices and go entry to entry and subtract. You could do that. Perfectly fine. But I'm going to use my handy dandy calculator. So I have to enter my matrices. So let's go back. How did I do that again? Anyone know? I pressed second matrix. And again, I'm going to edit. I'm going to choose that first matrix. Great thing is my dimensions are the same. 1, 2, 3 rows, 2 columns. Enter my new information. All done. Second mode. And now I'm going to go enter my second matrix. This time I'm going to go down to B to enter it. Same dimensions. Enter my new information. Second mode. And now let's type our problem. Our problem reads as follows. 2 times our first matrix, which is A, minus 3 times our second matrix, which is B. All set? Press enter. Voila. You have your answer. Our answer is the matrix -8, -3, 4, 1, 3, and 0. Please notice our dimensions for each of these matrices in addition and subtraction are the exact same dimensions as the matrix we started with. That's pretty awesome. Flip your paper over to the back and we have a multiplication problem. To do this multiplication, we're going to do the exact same process that we've done already. We're going to enter in our matrix. When we are doing these, we only want to use the calculator. They have a long, tedious process. So I'm going to go enter my matrix, second matrix, go over and edit, but this time I have to change my dimensions because there's only one row but 2 entries. So this is a 1 by 2 matrix. My calculator is helping me out. It's reminding me that's all I should see. -3 and 4. All done. Let's go into our second matrix. The second matrix, we're going to do the same process. Second matrix. go over to Edit, but this time go down to Matrix B. Notice my dimensions here is a 2 by 2, 1, 2, 2 rows, and 2 columns. So when I go to enter it into the calculator, I need to make sure I change it. Again, the calculator helps to make sure I get it right. So type in your new information. Just go ahead and get out of that screen, and now we're ready to multiply. Select our matrix A times our matrix B. And when we press enter, we're done. Remember, we talked about how I'm allowed to multiply because these two numbers are the same, and my resulting matrix will be a 1 by 2. And sure enough, it's 1 row and 2 entries. My answer is 1120. Okay? Now, the next part, or the remaining part of this assignment, goes over what is an augmented matrix. We need to review what is an augmented matrix. An augmented matrix is a way for us to be able to take system type equations or word problems and make it in a consolidated form where we only focus on the numbers. When you set up your augmented matrix, order matters. Alphabetical order to be precise. So make sure all your X information is first, your Y information is second, and any Z information is third. Remember, we moved to 3 by 3 matrices in this unit. And then all your answers, that's the stuff after the equal sign, no variables, will be all over here by themselves. So let's take a look. Here, we're given the system 2x minus 3y minus 6 equals 0, and x plus 2y plus 8 equals 0. Again, we want to line everything up. Make sure x's are with x's, y's are with y's, z's are with z's, and our constants are all over here. Well, when you look at this problem, you will notice we have constants with the letters. Not allowed. We need to move them all over here so they're on the other side of the equal sign. When I do that, their values change. So I'm looking for something that has a positive 6 and a negative 8 here. Okay? Matrices, when we look at our augmented, will also be horizontal in nature. The line will always be here. So when I look at my answer choices, there are 2 I can automatically eliminate because they don't match our setup. B and D. So now let's look at our numbers. Remember, when we move these over, we need to see a positive 6 and a negative 8, which is why A is the correct choice. Here are my x's, 2 and 1. Here are my y's, negative 3 and 2. To solve an augmented matrix, we used a brand new process. It was using our RREF function. And in order to get that, these are our steps. Step 1, we enter the matrix just like we just practiced. We second mode to quit out of the screen. We're going to hit second matrix to go and select this function. And when we do, we're going to have to go over to math this time and up arrow until we see RREF. We'll select that and then go back and select our matrix. Once we've selected our matrix, we'll press enter, and this is what we should see because our answers will be right here. We'll interpret the answers in just a moment, but let's go and practice our steps. So we have an augmented matrix we need to enter. We're going to go back, press second matrix. We're going to go over to edit, and we're going to edit the A matrix. So I'm going to press enter. This matrix is currently a 2 by 3, 2 rows and 3 total columns. So 2 by 3. 2, 3. Again, my calculator makes sure I get it right. 2, enter your entries. Once you're done, don't forget to second quit out of this screen. That is crucial. And now we're going to go and choose our RREF function. To do that, we are going to press that second matrix and go over to math. Go up until you see RREF, not REF, RREF. Press enter, and now we need to select our desired matrix. Second matrix, we're going to choose matrix A, that's where we just placed it, and press enter. What we see is our answer. The first answer where you see 1, that means X. This is my X answer. The second place where you see 1, that is your Y answer. And if this was a Z, you would see a third 1 down here, and that would be your Z answer. So let's write our answers down. We get -1 point, and we're just going to use 2 decimal places, 7.1 and -3 point. Oh, that should look very familiar to you. It's pi, 3.14. There are our solutions. This is my X value, and this is my Y value solution. Now let's try that with a 3 variable matrix. Remember, this is our X information, our Y, our Z, and these are our answers. As we match it back to the system, we need to make sure everything is lined up, which means in our very first equation, I should see a 2, a -3, a 1, and is this +6 supposed to be here? No, it's on the other side of the equal sign. But wait a minute, none of my answer choices have the 6 on the other side. Well, if that's true, if I moved it back over, it would have to be the opposite. So no matter what, this does not work. So it can't be A. Well, let's look at our next answer choice. Look at C. Over in C, we need to have a 2, a -3, a 1, and that 6 is positive on this side of the equal sign, but when I move it over, it's negative. Very good. All check. Let's look at the next line. A 0 for X, meaning no X values. Very good. 2 for Y, a -1 for Z. Looking pretty good. And that -5, if it was over here, when I move it to the other side, becomes a +5. All check. One more row to go. 2 for my X, no Y values. A -3 for my Z, and a 7, which is on this side of the equal sign. Check, check, check. C is my answer. Now we're going to actually solve the matrix. Again, we have an augmented matrix, and we are going to use our RREF to find the solution. So we're going to do the RREF. So let's go through those steps one more time. Okay, I'm going to clear this screen. We're going to go to our matrix. I'm going to make it so you can see it. We're going to press second matrix. We're going to edit our first matrix. And this time we have a 1, 2, 3, a 3 by 1, 2, 3, 4. we have a 3 by 4 matrix. Again, let's make sure we're clear. 1, 2, 3 by 1, 2, 3, 4. Again, my calculator is going to make sure I get it correct. That lets me know I have some more matrix over here to the side to enter. So let's enter our values: 2, -3, 1, and 6. Next row, 0, 2, -1, and -5. Last row, 2, 0, -3, and 7. Second quit takes us back to our regular screen. Now we're going to go choose that matrix again. So we got to go to second matrix. But we're calculating. Where do we go? Someone knows it. I know you know it. We're going to math, and we're going to go right up to RREF. Press enter. Go back and select your matrix one more time. Matrix A. Press enter. And notice again, this first one is my X value. The second one is my Y value. And the third one is my Z value. When I write my solution, I will write my X value of -1.6, my Y value of -4.2, and my Z value of -3.4. This is X, Y, and Z. Our very last problem, ladies and gentlemen, is the word problem. And in the word problem, we have to set up the system. I know we don't like it. We can do it. So let's start reading. And we're setting up an augmented matrix. We have a student who has saved $140 to purchase a bike. We know there's a total here. That helps me know I have something that's going to be set equal to 140. The money he has saved consists of $20 bills. Sounds like an X to me. $10 bills. And $1 bills. Money must stay with money. That is my very first equation. If this is a 3 variable, I need 3 separate equations. So let's look at our second equation. My second equation comes from the second part. It says he has a total of 21 bills. There's my total, but what makes up the bills? $20 bills, which is X, $10 bills, which are Y's, and $1 bills, which are Z's. These all make up my total 21 bills. One more equation to go. The number of $10 bills is 1 more than 4 times the number of $20 bills. So let's write that. The number of $10 bills, $10 bills were our Y's, is, there's that powerful little word that tells me equals, and it says 1 more than 4 times the $20 bills. Well, what represents 20? X. Because that was our very first one. And there's our third equation. We now take this information and we convert it to an augmented matrix. My augmented matrix, we're just going to take our numbers and to write our matrix. So it's 20, there's our 10, there's our 1, there's my line, and what goes on the other side of that line? The 140. My second row, 1, 1, 1, there's my 21, and the very last one we have to do some work because our X is on the wrong side. So we need to take that X and move it over to the other side, but when we do, it becomes -4. There's our 1Y, no Z's, and there's our whole number 1. Now that we have our augmented matrix, we're going to type it into our calculator to find our solution. And we do the exact same process as what we did before. So here we go. second matrix. I'm going to edit the very first one. This is now a 3 by 4 matrix, already set up. We just need to type in our entries. Go back to our regular screen, and now we're ready to calculate. How did we get to that calculation? Second matrix, go over to your math, up arrow to UC, R, R, E, F. Press enter, select your matrix. We're selecting matrix A. Press enter, and we are done. My solution is that our student had 2 $20 bills, 9 $10 bills, and 10 $1 bills. How do I know? Because X represented the 20s, Y represented the 10s, and Z represented our 1s. So when I write my final solution, it is using words 2 $20 bills, 9 $10 bills, and 10 $1 bills. And that is how I would write my solution. See you tomorrow, ladies and gentlemen, when we go over the next part of our unit review, our final review.